Well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good, Mr. Q. How's your home plate? Let's go. All them applications, right? All right, all right. All right, so warm-up number 50 is on the screen. Number 1, read, simplify, and round your answer to the nearest 10th of square root of 10. Number 2 says graph f of x equals x squared without a table. Then write the rule and graph the transformation if g of x equals a times f of 1 over bx minus h, close parentheses, plus k, where the parameters are a equals -1, b equals 1, h equals 3, and k equals 4. Number 3 reads, factor completely. A is 3x squared minus 6x minus 45, and b is 2x squared plus 7x plus 3. Number 4 says divide the polynomial with synthetic division, or the polynomials with synthetic division, and we are giving parentheses x cubed plus 5x squared minus 17x minus 21, close parentheses, divided by x minus 3. So should be able to remember that by now. And number 5 says graph, and they give us part A is y equals -4, and part B is x equals -2. I'll give you a couple more minutes for that. Copy that and go warm up. All right, so number 1, what'd you get for number 1, Avery?
I got 3.3.
3.3?
Yeah, about.
About, okay.
Equals about.
All right, well, that, I think it's pretty close. Who got something else? Alvaro, what'd you get?
I got approximately 3.1.
3.1, let's check. This is in between 9 and 16. That means if we subtract, that's 1. Subtract, that's 7. So 1 divided by 7 fits in there 0 times. Add a 0 fits in there once. That's 7. Subtract, that's 3. Add a 0 fits in there 4. But the 4 does not make this one into anything greater. So this is 3.1 approximately. All right. Come on, Avery. Try to wing that one. Come on. Let's go. Let's go to number 2. Number 2, let's graph that one. So let me do that right above. All right. So it says graph without a table. So here's my coordinate plane. And like I said, by now, the parabola should be automatic. We start with our vertex at 0, 0, point of origin. And here's my parabola. And then we're going to graph that transformation. So I'm going to substitute those values into the general form. So A is -1, B is 1, H is 3. This is squared because it's a quadratic, and K is 4. If I rewrite this, we get G of X equals -1 times F, parentheses 1 over 1x minus 3, close parentheses, squared plus 4. Let me rewrite that so we can see the end transformation. G of X equals -1, and I'm going to make that big so we can see the big, not pink elephant, but the red elephant in the room, which is -1, parentheses x minus 3 squared plus 4. So H is going to take us to the right 3 steps, and K is going to take us up. So I'm going to take the vertex 0, 0, point of origin. I'm going to move it 3 to the right, 4 up. So 1, 2, 3 to the right, and then 1, 2, 3, 4. We end up over here. If that was the end of it, I would sketch my parabola over here. However, what does this -1 do to any function? Doesn't matter what the function is. What does that do? What do you think, Alexandra?
I don't remember.
Okay. Avro, what does that -1 of A do?
It flips it upside down.
Upside down, or it inverts all the points. So that means it's going to end up like this. All right. Let's go to number 3. Let me make some space here. To factor this, we need to completely check for GCF. GCF is 3. We're left with 3x. We're left with x squared minus 2x minus 15. Factor that trinomial. Negative 15 is our product. Negative 2 is our sum. Factor the negative 15 that add up to negative 2. That's negative 5 times 3. So here in parentheses, the x squared becomes x times x. We bring down the negative 5 and the positive 3, bring down the 3, and these are my factors. Let's go to this one. Can we? Is there a GCF for part B? No, so that means I go straight to factoring. However, there's a leading coefficient. So the leading coefficient is 2. 2 times 3, that's 6. That's our product. Our middle coefficient, that's 7. That's our sum. Factors of 6 that add up to 7. That's 6 times 1. However, this one that has a leading coefficient, we cannot write our factors straight just from here. We need to do grouping. So I bring down, rewrite this. I write 2x squared, but instead of 7x, we write what we came up with here, which is 6x plus 1x. Bring down the last term, which is plus 3, and now we can group 2 terms at a time. So the first two, there's GCF of 2x, we're left with x plus 3. The last two terms, GCF of 1, x plus 3. So we're left over, what's the same here and here, x plus 3. And what is left over after that, 2x plus 1. And those are my factors. All right, let me go to number 5 and I'll come back to number 4. So like that, those of you that are still copying that. Number 5, it says graph. So here's my coordinate plane. And for this one, they give us y equals 4, y equals negative 4. So I go down to the y-axis, negative 4, 1, 2, 3, 4, plot my point and sketch my line. There it is. For part B, x equals negative 2. Negative 2 is 1, 2. Negative 2 is right there, plot my point, and the line going straight up and down. All right, let's go to number 4. Yeah, I love synthetic division, right? Am I right? Am I right? Like, you're right, Mr. Q. Oh, good. So let me make some room for this one. So, let's see. So for synthetic division, once again, first step, check and see if it's in standard form. This is the 3rd degree, 2nd degree, 1st degree, 0 degree. Is it in standard form? Yes. Are there any powers missing? Nope. Look at this one, 1st degree, 0 degree. Standard form, yes. Any powers missing? No. So I take the divisor and I do x minus 3 equal to 0, add 3, x equals 3, and that's what I'm going to start for my synthetic division, positive 3 over here. And for the dividend, I'm only going to use the coefficients and the constant. So what is a coefficient for the first term? That's 1. Second term, 5. Third term, negative 17. And the constant, negative 21. And just to remind you, this is 3rd degree right here, 2nd degree, 1st degree, and this is 0 degree for my constant. So let's get this number 1, bring it down here. And we start our multiplication. What is 3 times 1? 3 times 1 is 3, goes right above the line. Combine 5 and 3, that is 8. We'll do it again. 3 times 8, that's 24. Combine negative 17 and 24, that gives me 7, positive 7. And let's do that again. 3 times 7, that's 21. And negative 21 plus 21, that gives us 0 remainder. So now that we did the division, these numbers down here, they correspond now to, not to the 3rd degree. Now this one, the one is 2nd degree. So this is x to the 2nd degree. That means 8 is to the 1st degree. So it's 8x to the 1st degree. And that means the 7 now is our constant. And this is my quotient. All right, what does that mean, Mr. Q? That if I was to multiply this times the original divisor, which was x minus 3 divisor, I would end up with the original polynomial that we started with. All right, do me a favor, so I'll come to you with a warm-up. Yeah, we've been working on this already, right? All right. So our agenda for today, we got warm-up number 50. Once again, number 50 we just finished, and we're moving on. Today we're going to be looking at parabolas. We're going to get more engaged with that to see where they come from and so on and so forth. And tonight's home play is pages 183 and 184, numbers 1 through 4 and 7 through 8 only. So it's only 6 problems. So that means on page 183, you're only going to do numbers 1, 2, 3, and 4. And on page 184, only 7 and 8. Now I'm breaking down this lesson a little bit more into parts because they put too much stuff in it, and I just wanted to develop a couple of things before we did the whole thing, okay? So your asynchronous code for Nearpod is, let's see, Nearpod code ISV9W. Make sure you write that down, ISV9W. Your asynchronous code, once again, ISV9W. ISV9W. All right. Your previous home play was on pages 169, 170. Make sure you turn that in, please.
Mr. Q,
Yeah.
can you go back to the synchronous code real quick?
ISV9W.
Thank you.
You're welcome. Turn that home play in. I'll give you 1 minute to do that. Just a reminder, guys, I usually post the home play right before the day starts. So if you have time before you get your day started, just go to campus and submit. I see some of you do that, so thank you for that. So by the time you do that, hopefully by now, this time of the year, every time you do your home play, the day of the lesson, you take pictures of everything and you have that stored and ready to submit when the following day comes when we meet, okay? Once again, as you are submitting that, some of you already did, get your Cornell note ready. You do need a fair model. You need a blank sheet of paper after that. And after the blank sheet, you're gonna need at least 6 coordinate planes with domain and range from -6 to 6. Get those ready, please. We will need them. All right, so reminder, home play for tonight, pages 183, 184, numbers 1 through 4 and 7 through 8. 1 through 4 and 7 through 8. All right, y'all ready? Yes, Mr. Q. Everybody go like this. Bear with me because today is going to be like really packed with a lot of ideas and stuff. You're going to be like, man, Mr. Q, I see where you were going with all this stuff. Yeah. So you're going to see how we develop a couple of things and we get into today's concept. So our objective for today, I can write and graph a quadratic equation of a parabola. Let me repeat that again. I can write and graph a quadratic equation of a parabola. Now, according to the objective, what are we doing today? We are writing and graphing. What are we writing and graphing? What is our main concept for today, Manny? Main concept for today.
The parabola.
Parabola. So in your FAIR model, write in there parabola. I'm going to break it down. Even though we've been working with parabolas ever since middle school, you guys remember? So parabola. What are parabolas? And now you're going to see some of the definitions that we've used. Some of the terminology is going to sound familiar. All right, here we go. Definition. Parabola is the set of all points equidistant from a line and a point. The line is called the directrix and the point is called the focus. Make sure you write directrix in blue, focus in red. Once again, a parabola is the set of all equidistant points from a line and a point. Once again, the line's called the directrix and the point's called the focus. All All right, so let's sketch those. So the point, it's called the focus. There it is. And underneath that, I'm going to draw a straight line. Leave a little space, and that's called the directrix. Now, what is the familiar word here? Equidistant. You guys remember that from when we covered circle? Yes? So what does equidistant mean? It means that it's equal distant, equally distant, okay? So here we go. Writing utensils down, look up to the screen. Let me develop this for you guys really quick. You need to know this in order for us to move on to the next part that's coming in the lesson. So writing utensils down, look up. And don't copy this that I'm sketching because I'm just gonna sketch something to get your noodle ready for what's coming. Ready? Here it goes. So according to the definition, a parabola is formed by the set of all points equidistant from what? From two things, the focus and the directrix. So what does that mean, Mr. Q? That if I was to sketch a point that's equally distant from the focus to the directrix, that means it will be somewhere right here. Do you agree with that? Yes? So check this out. If I was to continue doing that, that means I'm gonna end up with a bunch of little points that way and a bunch of little points that way. And if I continue filling in those gaps of points, it creates a parabola. But you're saying, Mr. Q, then how are those the same distance? So you're not copying this, you're just paying attention. The obvious one that makes sense is from here to here and from here to here. Do you guys notice this and this are the same distance? Yes? Okay. The one that maybe doesn't really make sense is this point over here. How is this the same distance? Well, let me show you. Look up. Look what I'm going to do here. Do you see a little square forming here? You're like, oh yeah. And what do we know about squares? That one side measures the same as the other side. So do you agree that this point is the same distance from the focus to the point and the distance from the directrix to that point? Yes. That's why the definition for a parabola is that all these points are the same distance from the focus to the directrix. And that forms a parabola that looks like this. So copy that parabola, please. Make sure you put arrows at the end so like that we know it continues going. Just wanted to make sure I explain that before I get into the next part. So according to the definition, we have a bunch of points here that make the parabola, and all these points are equally distant from the focus and the directrix. Okay, so let me show you a non-example. I'm going to place a point here, and I'm going to sketch a bunch of points equidistant around that point. You're like, Mr. Q, it's not centered. Okay, my bad. There it is. Okay. So think about it. Why is this one not a parabola? Think about it. All right. Why do you think that one's not a parabola?
Because
Obviously, because it doesn't look like it. But why, in regards to a definition, think about definition. Why would it be not a parabola?
the directrix line is supposed to be a line, not a circle.
Yeah, its directrix is missing. So these points are equidistant only from the center. That's why this is known as a circle. Whereas the parabola needs two things that needs to be equally distant from the focus and the directrix. Yes. Okay, watch out, Aiden. All right, let me give you another one. How about this one? Is this obvious that it's not a parabola? Yeah? Yes, because it's a square. How about this one? Yeah, that's not a parabola because it's a triangle. And how about this one? That's not a parabola because it's a straight line. You guys see the face? Yeah, pretty good, right? I'm telling you, I got this. All right, hashtag this. What makes a parabola a parabola? Hashtag what? Let's see, Emily H. Hashtag what?
Hashtag focus.
Focus. Yes, it needs to have a focus. Hashtag what? Zach?
Parabola.
Oh my goodness. Wow. Woo. You just burned some major chemistry right there in your noodle. All right, who can give us another one, a good one? Let's see, Viv. Hashtag what?
Equidistant.
Equidistant. Equidistant. Yeah, and you can do points and whatever case, but it needs to have all those components. All right. So we're just missing one more hashtag, which would be directrix or focus and directrix, and you just elaborate on what you can add there. Okay. All right, let's move on. So now that we know what a parabola is, today we're going to be talking about the standard form equation of a parabola. Look up, please. Standard form of a parabola. You've seen it before. Don't copy this. Look up. Y equals ax squared. Does that sound familiar? Yes, that's a parent function. Okay. How about the other way around? Ax squared equals y. Yes, we've seen this before. Okay. However, today we're going to use something similar to this, but I want to get you guys to understand where it comes from. So today I'm going to do deriving the quadratic equation of a parabola. I'm not going to derive the quadratic formula. That was something else. This is the quadratic equation of a parabola. So to get started, I'm going to start off first with, let me get a coordinate plane and write the title really quick, deriving the quadratic equation of a parabola. Okay, deriving the quadratic equation of a parabola. All right, so I'm gonna go pretty fast and I'm gonna stop and have you copy part of it. So at this time, I just need your attention to the screen. You'll finish copying the rest in a little bit, okay? I just wanna make sure that we understand where we're at and what we're doing with this, okay? All right, here we go. Write your utensils down, look up to the screen. Focus, please. Here it goes. So one thing that we know, this is a quadratic coordinate plane. If that is a coordinate plane where these two axes intersect, this point here is called the point of origin. Hands if you agree with that, yes? And what is that coordinate? Everybody knows that that coordinate is what? 0, 0. Okay, so far so good, right? Okay, so if I was to sketch a parabola using this coordinate plane and you're just paying attention, I need a focus. So I'm going to place a focus right here. Focus. And that focus, I'm going to label that X is 0, and that's a point that I just made up and I placed it there. I'm going to label it P. So 0, P. Okay. But what do we know? That if I was to sketch a parabola going through that point of origin, I need a what? A directrix. That means it needs to be the same distance from the point of origin to the focus, same thing from the point of origin to the directrix. So I'm going to place a point down here and I'm going to sketch a line going through there, and you're just paying attention. I'll have you copied a little bit. Oh my goodness. There it is. And this is known as what? The directrix. Okay. So the directrix has a coordinate as well, because I have a point right here. It's 0. Now check this out. If for the focus I use 0, positive P for above the point of origin, what am I going to label the directrix down here? 0 what?
Negative P.
Negative P, that is correct. So negative P, there it is. Okay, so hold on, before you copy, look up. So do you agree that this distance, we'll label it distance 1, is the same as this distance, distance 2? Do you agree with that? Yes, so that means down here, just so that I keep it in mind, distance 1 is the same as distance 2. Copy that really quick, please. All right, so let me zoom in a little bit more so you guys can, those that didn't see that well, okay, there it is. Okay, so what do we have? Once again, we started with a coordinate plane, the point of origin, which is 0, 0. I placed a point out of nowhere here. We call it the focus, so I label that 0p for point. There it is. But we said that this distance has to be the same if I was to sketch a parabola going through the point of origin to another line down here, which is known as a directrix. And we saw that on the definition. So I placed a point here, and that point is 0, negative p because it's below the point of origin. Are we there so far? Okay. Writing utensils down, look up to the screen. So just to be clear, we have our coordinate plane here. That means this is our x, and this is our y axis. Everybody agree with that? Yes? So now check this out. I'm going to place one more point so that I can graph my parabola, but the parabola is coming from here. Look, I'm going to move this point. Look up. You're just paying attention. And I'm going to move the point following the parabola path that it's going to go maybe through here. There it is. Okay, and let me extend this directrix. Okay, now check this out. This point, I'm just going to label it x, y. Okay, there it is. All right, so you're just paying attention. Look up. So question, now that we did the definition earlier, do you agree that this distance would be the same distance from that point to the directrix? You're like, yes, Mr. Q, so there should be a point here. That point, let me see. The x value is x. What is my y value? Negative p. Are we there so far? Is that making sense so far? Yeah? Okay. So now, since I moved this point over here, now check this out. I moved this point over here. That means that path for the parabola is going through there. That means this is my new distance 1, and this is my new distance 2. Copy that, please. All right. So here we are. We started with first these two distances, and we said that distance 1 is equal to distance 2. So if I was to do half of my parabola this way, that means that this distance is still the same as this distance. So far, so good. Okay? So if I was to do the same to this side, that means my other side of the parabola is going to reflect, whoa, that's an ugly, that's an ugly curve. Sorry, guys. Hold on. All right. There you go, a little bit better. Yeah, my pixelation on my tablet sometimes doesn't allow me to do nicer stuff. Okay, so there it is. It's reflecting on that side. Okay, so check this out. So what I'm gonna focus on right now, guys, I'm gonna focus on these distances. This one and this one, okay? All right. So just pay attention, please. Writing utensils down, look up to the screen, and I'll have you copy in a little bit. So I'm gonna start with distance 1. Distance 1, I'm gonna use the distance formula. Check this out. What is my distance formula? X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Distance 1 is square root of parentheses with a negative in between squared plus parentheses with a negative in between squared. Okay, look up. Before you copy this, look up, look up, look up. So I need to fill this in for this distance. Look up, please. This distance, distance 1. So I need 2 points. I have my first point here, which is the focus, and the other point, which is x, y. But I need them labeled for this distance. So I'm gonna use the focus. This is gonna be my x sub 1, y sub 1. That means this point over here is what? X sub 2, y sub 2. So look up before you copy. Check this out. So according to my formula, this says x sub 2 minus x sub 1. So what is x sub 2 over here? Let's see. X sub 2 is x. So I'm gonna write x. Over here, what is x sub 1? X sub 1 is 0. Next, y sub 2. What is y sub 2 here? Y. And what is y sub 1? Y sub 1 is p. Copy that really quick, and then I'll continue from there. And once again, I got those two values from these 2 points. This point, which is the focus, and the point xy right here. Okay, I'm using this distance for distance 1. Okay. All right, I'm gonna scoot up. So let's continue developing this distance right here. So I'm gonna do D1, let's do this together. Now that we have our values. What is x minus 0? It's still x, we're left with what? X squared. Plus, what is this? Y minus p squared. That means I do this. Look, I'm gonna show it here. Y minus p times y minus p. Let's do another one. D distance 1. We got square root of x squared plus, what do we do here? Let's distribute. What is y times y? Y squared. What is y times negative p? Negative py. What is negative p times y? Negative py. And what is negative p times negative p? Positive p squared. Distance 1, we end up with x squared plus y squared. Negative py, that's negative 2py plus p squared. And we'll stop right there. So, do you agree that this we got from these 2 points over here? Yes, Mr. Q, that's what we started with. Are we there? Okay, so we're up to right there. All right, so let's do the same thing for distance 2. So right on this side, on the right, I'm gonna write D2 equals to square root. Then we have parentheses x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. All right, so then we're gonna do distance 2 is square root minus squared plus parentheses minus squared. All right, now we need values. So let me scoot back up so I can see the graph. So let's see. What distance are we looking at now? We're looking at this distance right here, distance 2. So this point, and now this point, which is the point on the directrix. So check this out. I'm gonna label this one my x sub 1, y sub 1. And the other point, it's still what? X sub 2, y sub 2. Are you guys following? Yeah? Okay, let's substitute values. Let's see what we get. What is x sub 2? X sub 2 is x. All right, what is x sub 1? X sub 1 is, oh, it's x, okay. Do you guys see that? X sub 1 is x right here. Yes, okay. What is y sub 2? Y sub 2 is y. There it is. What is y sub 1? Y sub 1 now is negative p. Okay. So write that in there and we're going to develop this together. Here we go. All right. So distance 2 is square root. What is x minus x? 0, so this cancel. So that leaves us with this, parentheses, y. What is negative times a negative? Positive p, and we write it twice because it's squared. Y plus p. Distance 2. Let's distribute that. We get y times y, y squared. y times p, that's py, p times y, that's py, p times p, that's p squared. So distance 2 is square root of y squared, well, plus 2py, py plus py, and then plus p squared. Make sure you copy that, please. All right. So according to what we have now, check this out. We said that D1, distance 1, is equal to distance 2. So let me bring that equal sign down here. So what is D1? Oh, D1 is this, Mr. Q. All right, let me write it. Square root x squared plus y squared minus 2py plus p squared. And what is D2? Oh, D2 is this. Square root y squared plus 2py, 2py plus p squared. All right, so since we are deriving, guys, we need to get rid of everything that we can. So since both sides have a square, that means I can do square root. I can do square to both sides. That cancels that. That cancels that because it's the same on both sides. I'm left with x squared plus y squared minus 2py plus p squared equals y squared plus 2py plus p squared. Let's continue. In order to send everything that's the same to each side, I would start, let's say, sending p squared to the other side. So I would subtract p squared, or anything that looks the same, we're going to eliminate. Because if I subtract p squared from this side, I need to subtract it from over here. What else can we eliminate?
Y squared.
Y squared and y squared. Yes, so if we subtract y squared from each side, there it is. So what does that leave us with? On this side, it leaves us with x squared minus 2py equals 2py. And at that point, I'm going to leave x squared by itself. So I need to do what? Add 2py to each side, add 2py to each side. And ladies and gentlemen, x squared equals 4py is the standard form equation of a parabola. You're like, what? Yeah, so now let me show you how lucky you are. When I got to this portion of my sessions, I would have a pop party on this on the next section. You guys needed to do the deriving the quadratic equation by yourself from a blank sheet of paper. But since we're not in person, I'm not gonna have you memorize that just yet. I'll give you guys some time to chew on it. However, show me if anyone's talking to you, we're following along all the process now that we know all the components. Yeah, 5, 5, 5. Yes, we should be able to follow because we did practice on the distance formula. We know our coordinate planes, we know how to label stuff, and we know how to substitute values. And now let me zoom out so we can see the beautiful artwork. Look at that. You guys see that it looks like a heart? Aww. Some of you are like, I don't know about that, Miss Q. That's what we call deriving the quadratic equation of a parabola, okay? So what does it come from? It comes from these two distances, distance 1 and distance 2. I just use the distance formula and substitute values to develop and derive x squared equals 4py. This is our what? Our standard form equation. So with that said, let's write that down. Standard form equation of a parabola. This is known as a vertical parabola. What was it? X squared equals 4py. Once again, in blue, vertical parabola is known as x squared equals 4py. Once again, vertical parabola is x squared equals 4py. That's the form we're going to be working with, guys. Okay? All right. There's other ways that if we were to manipulate the equation, it would look like this. 1/4 p times x squared equals y. by sending 4 and p to the other side. And another way that is written, sometimes they substitute this with the letter A, and it looks like this. Remember, this is the most common used one. Yes. All of these stem from here. Okay. Now, this is known as what? A vertical parabola. What does that mean, Mr. Q? That it's going to either open up like this or downward. Which direction? Upward or downward? That means vertical. That's why we call it a vertical parabola. Now, what else do we need for vertical parabolas? We need the directrix. Now, make this note, please, because some students missed it on the previous session. The directrix, whenever they give you y equals to a certain number, because we're going to be graphing right now. Here it goes again. Whenever they give you that the directrix is y equal to a particular number, well, guess what? We're going to be graphing a vertical parabola. And which equation are we going to use? X squared equals 4py. Let me repeat that again. Whenever they give you values to graph and you see that the directrix is y equal to a number, whether positive or negative, that means we're going to be graphing a vertical parabola. That means we're going to be using which equation? X squared equals 4py. Now, Mr. Q, why are you being so specific? Because we also have what we call horizontal parabola in red. Now think about it. Let's see. Look up, look up. If vertical parabola is x squared equals 4py, what do you think the horizontal parabola equation would be? This is about the x. The horizontal one is going to be sideways. What do you think it's going to be for the equation? What do you guys think? What do you think, Manny? This is x squared. What would be the horizontal?
Y squared equals 4.
Let's go, Manny. You remind me of me in elementary. Let's go. So yeah, y squared equals 4px. And what do you guys notice? All we did is substitute the values for x and y. We switched those because now we're going to be graphing according to the y-axis, okay? And of course, the other derivations or the other forms look very similar. Look, 1/4 p y squared equals x, and a y squared equals x. Yes?
How do you get the ax squared equals y from the x squared equals 4py?
Okay, so ax squared equals y. So here, look up. So I started with this. If I divide both sides by 4p, I end up with this, yes?
Yeah.
And then all they do is replace this and say that this is a coefficient of x squared, and they just label it a.
Okay.
It's all about labels. But once again, we're not going to use these two down here. This is the most common one. The bottom one is the most common one we've been using since Algebra 1. But now we're going to be using the top one over here, okay? So check this out. Horizontal parabola. That means it's going to open sideways like this, either to the left or to the right. And notice it's opening horizontally. And it also needs a directrix. Look. However, look at this directrix. Whenever they give us values where the directrix is x equals a number. Let me repeat that again. X equals a number, whether it's positive or negative, we're going to know to use which equation? Y squared equals 4px. Why? Because it's going to be a horizontal parabola. What if the directrix is y equals to a number? Then we're going to use x squared equals 4px. What if they give us a directrix being x equals a -5? Oh, well, we're going to use the y squared equals 4px because it's a horizontal parabola. Does that make sense, kind of? All right, so let's get started with an example. Y'all ready? So before we get started, remember, we're going to use only these two forms. For the vertical parabola, x squared equals 4py, and for the horizontal parabola is y squared equals 4px, okay? All right, example 1, copy this. It says, write and graph the equation of the parabola passing through the point of origin and with the focus of 0, 2, and directrix y equals -2. And repeat that again, write and graph the equation of the parabola passing through the point of origin with a focus of 0, 2, and directrix y equals -2. I'll give you some time so you can get that ready. Copy and go. All right, before I continue, write your utensils down, look up to the screen. Let me do this before we get started with anything. we said that if they give us something to graph and the directrix is y equals to a number, what kind of equation are we using, guys? What kind of parabola are we graphing?
Vertical.
A vertical, that is correct. For those of you that missed it, let me go back to the previous screen. Here it goes. Look at that one. Look at the vertical one. It says that they're going to give us y equals a number. So that means it's going to be a vertical parabola. That means we're going to use this equation right there. Look at it. Do they give us y equals something? Yes. Okay. So let's get started. Let me zoom out. Okay, there it is. So we need to write an equation and graph. But just to be clear, for those of you that don't see it, I'm going to start with my directrix. What's my directrix? Y equals -2. Let's plot that, -2, which is right there. And sketch your directrix. My directrix is going through -2 of y. Now it's becoming a little bit more clear. Let's sketch the focus. The focus is 0, 2, 0, 2. There it is. And what do we know? That the parabola are all the points equidistant from those 2 points, the one on the directrix and the one on the focus. Do you guys see that? Yes? So now that we established which kind of parabola we're going to use, let's write our equation. What's our equation? Our equation is, let's write over here, x squared equals 4py. Okay. Now, before I continue to graphing my parabola, writing utensils down, look up to the screen. Remember when we did deriving the quadratic equation? Look up. What did I label this focus when I didn't have numbers? What did I label it?
0p.
0p, that is correct. That means my focus, whenever they give you a focus, that's where we're going to get our p from. So that means here I'm going to substitute 2, and I'm going to bring down x squared equals 4 times 2 times y. So now the equation that I'm going to use specifically for the focus on the directrix is going to be x squared equals 8y. All right. So now that we have that, let's get a table. X, y. Domain, -2, -1, 0, 1, 2. Do we know how to come up with our y values? Yes, substitute values into the equation. So I'm going to use this equation. So I'm going to substitute values in there. Squared equals 8y. So my first value is -2. -2. What is -2 squared? 4. 8y. Let's solve for y. Divide by 8. 4 eighths is 1/2 equals y. And I label that right here, 1/2. I'm going to do the same for the next one. So that was -2. So I'm going to use parentheses squared equals 8y. What's my next value? -1. So what is -1 squared? 1 equals 8y divided by 8. So that gives us 1/8 equals y. Okay. So that goes right here, 1/8. And let me do one more. We got parentheses squared equals 8y. And now the next value is 0. 0 equals 8y divided by 8. So that means 0 equals y and 0. Okay, so let's plot these points really quick. -2, 1/2. -1, 1/8. There it is. Very close to the axis, and 0, 0. Do you guys see the parabola forming? So who can give me the value of when x is 1 without doing any computation?
1/8.
That is correct, 1/8, because it's going to reflect on this side. So what is our value for x equals 2?
1/2.
1/2, thank you. And that is how we graph our parabola. given the focus and the directrix, and it's going through where? Through the point of origin. All right, show me reference. I'll come to you so far up to right there where we're at. See 5, 5, 5, 4s, 5, 4s. Okay, let's do another one just to make sure we got this. Okay. Copy this next one. Example 1Q. It says, write and graph the equation of the parabola passing through the point of origin. The focus is 0, 5, and the directrix is y equals -5. So what is the directrix? Y equals -5. So what kind of parabola are we going to have? Elizabeth.
A vertical parabola?
A vertical, yes. Yeah, vertical parabola. Okay. So we start with the directrix. The directrix is -5. There it is. So I sketch my line going through there. My focus is at 0, 5, 0, 5, which is right there. Okay. So that means my parabola is going to be through the point of origin. Yes. All right. So we said it's a vertical. So I'm going to use x squared equals 4py. And we said, where do we get the p value from? From the focus. So we're going to substitute 5 in there. So we bring down the x squared equals 4 times 5y. X squared equals 20y. All right, let's graph. We need a table. X, y. Values for x are -2, -1, 0, 1, 2. So let me show you the process for this again. Parentheses squared equals 20y. My first value is -2. -2 squared is 4 equals to 20y. To solve for y, divide by 20. What is 4 over 20 simplified? That is 1/5 equals y. That goes right here. 1/5. 1/5. All right. We're done with the first value. Then we go to the next value. Parentheses squared equals 20y. So that's -1. What is -1 squared? 1 equals 20y. Divide by 20. So 1/20 equals y. That goes right here. 1/20. Let's do one more value. Parentheses squared equals 20y. 0 squared. So this is 0 equals 20y. Divide by 20. It's still 0 equals y, so right there. Let's graph that. -2, 1/5. 1/5 is about right here. -1, 1/20, very close to the axis. 0, 0. And do we know the values for the other two? Yes. 1/20 and 1/5. 1/20, 1/5. And there's our parabola. Did we write an equation? Yes. Did we graph the equation of the parabola? Yes. Show me how come you are up to right there. Yeah, 5, 5, 5, 4, 5. Okay. One last one. Yes, just to make sure we got this. All right. Here we go. Example 2. You don't need the instructions, but once again, the instructions read, write and graph the equation of the parabola passing through the point of origin. Once again, it's passing through the point of origin with focus 5, 0 and directrix x equals -5. What kind of parabola do we have now, Avery, with the directrix x equals?
Horizontal.
Horizontal, yes, that is correct. Bam, let's go. You must have drank some apple juice or orange juice, right? Some kind of juice. You guys know why? Yeah? Because it's made from concentrate, yeah? All right, let's plot our directrix at x -5. -5 is right here. Let's get you a line going through there. There it is. Oops, it's a little crooked. Hold on. There it is. My focus is 5, which is over here. So that means my parabola is going to be going through the point of origin. So that means it's a horizontal one. So I'm going to use y squared equals 4px. Where do we get the value for p? From the focus. So instead of p, we're going to substitute what? 5. So we write y squared equals 4 times 5 times x. Y squared equals 20x. So this is our equation. Let's get our table. X, y. Now check this out. Since this inverted everything, do you guys notice that it inverted the equation? Yes? So now we're not going to start with the domain. We start with the what?
The range?
The range. So our range is -2, -1, 0, 1, 2. All right. So the substitute value. So here squared equals 20x. So I'm going to substitute -2. That's 4 equals 20x divided by 20. So that is 1/5 equals x. So I'm going to write that here, 1/5. I'm going to do the next value. Squared equals 20x. -1, that's 1 equals 20x divided by 20. So that is 1/20 equals x. That goes right here. And of course, if we do the 0, we're going to end up with 0. Let's plot those points. -2 of y, pay attention to this part, -2 of y, 1/5 x. So -2 of y is down here, 1/5 x is over here to the positive side, so it's about right there. -1 of y, 1/20 of x. -1 of y, 1/20, 0, 0. And if you notice, if we reflect it to this side, then we end up with 1/20 and 1/5, 1/20, 1/5. And there is our horizontal parabola. Woo, let's go. And I love these. You guys good with these? Yeah? Show me your favorite talking to you with these. 5, 5, 5, 4s, 5, 4s. Okay, so once again, what is the main idea with this? That we need to really focus, see what I did there? We need to really pay attention to the directrix in order to know which kind of parabola we're going to graph. If it says directrix of x, it's going to be a horizontal parabola. If it says directrix of y, it's going to be a what? Vertical parabola. Okay? I'll stop right there, guys. That's our session for today. Once again, if you need extra support, tutoring right after lunch, be there or be elsewhere. Have a good one. Peace. Bye.